Okay, 20c. To clear a fraction, we're going to multiply by our first denominator of x minus 5. That gives me x over minus 5 over x minus 5 is 1. And 8 times x minus 5 over x. Then I'm going to multiply each fraction by x to clear my second denominator. So I get x equals, well, 8 times x minus 5 because these x's reduce. X over x equals 1. Then I'm going to distribute 8x minus 40. Then I'm going to get all of my x's to one side. So I'm going to subtract 8x to the other side. So I get negative 7x equals negative 40. And then I'm going to divide by negative 7. So x equals 40 over 7. My extraneous solutions are x cannot be equal to 5 or to 0. Because if I plug in a 5, 5 minus 5 is 0. If I plug in a 0 for the second fraction, then that would make my denominator 0. But 40 over 7 is not equal to 5 or 0, so I have one real solution. Then for the last one, I'm going to go ahead and factor my denominators before trying to clear my fractions. That's going to help me see some factors that match. If I have factors that match. So I factored this wrong. Let me try that again. I need to take out a 2, and I'm left with 3x plus 1, because both of these are divisible by 2. There we go. 2 times 3x is 6x, and 2 times 1 is 2. That helps because then I have two of my factors that are the same in the denominator. So these factors of 3x plus 1 match, which means if I multiply the 3x 1 times each side, they reduce on both sides, and I get 4 over 2 is equal to 2. Now I could multiply by my denominator again, or I could just reduce this fraction now. 4 divided by 2 is 2, so I get 2 equals 2, which is always true. There should be infinitely many solutions, but you have to list your exclusions. So x cannot be equal to whatever makes my denominator equal to 0. So in this case, if I set 3x plus 1 equal to 0, I subtract the 1 to the other side, and then I divide by 3, I get negative 1/3. If I set 6x plus 2 equal to 0, I would also get negative 1/3. So x cannot be equal to negative 1/3, but any other solution it can. So this is infinitely many real solutions. And then 21 is our last problem for the practice test, and it says solve the following equation for g. So I'm going to start by multiplying by my denominators. My least common denominator is gxy. I'm going to go ahead and multiply by all 3 of those denominators at one time. You can do them separately. When you do them all at the same time, you need to be careful about what reduces. So only if you have the factor in the numerator and the denominator at the same time does it reduce. So g over g is 1. That leaves me on the left of my equal sign with x times y times 1, which is just xy. In my second fraction, the x is reduced, so g times y times 1 is gy. And then I'm adding my next fraction where my y is reduced, so 2 times g times x is 2gx. Now, remembering what I'm solving for g, so I want to get g isolated, which means if I want to get it out of everything on the right-hand side, let's take it out as a greatest common factor. So the left-hand side is not going to change. But if I take that out as a greatest common factor, it's the opposite of distributing. So g times y would give me gy, and g times 2x would give me 2gx. And then to get g by itself, right now it's g times this set of parentheses. So we're going to divide the set of parentheses to the other side in order to get rid of it. Uh-oh. It's y plus 2x. So the y plus 2x reduces, and the g is all alone. So g is equal to xy over y plus 2x. That's xy over y plus 2x. Please make sure you write it as equation because you are solving for g. That's it.